Hello friends, welcome to my channel Mr. Physics. In the last video, we studied about how to calculate the number of disk windings. Like we calculated number of plane disks are 36 and number of turns per plane disk is 18. In one disk mein, how many turns are there? Plane disk. And number of tab disks are 8 and turns per tab disk is 14. Okay, today we are learning about the size of the strip for plane disk. So plane disk conductor size is how much? Width and depth. Similarly, tab disk also width and depth is we are calculating. First, to understand, to get the plane's disk the size, we have to know about the window height. After getting the window height only, we'll get the size of the plane disk. Like we have to, based on our experience, we have to take the window height. Like plus or minus 10%. Here they given, see, 10% plus or minus approximate of window height may not affect much on the performance figures. Okay, so we assumed the window height is 620 mm initially. Okay, based on the experience we calculate. Okay, now to understand the size of the strip, we have to remove all the gaps. See, this is a coil. This is a coil totally. Okay, plane discs are also is there and tab disc also is there. Okay, we have one disc to one disc gaps are there. Plane disc gaps, tab disc gaps, disc tabs and plane disc tabs, everything gaps are there. First we'll remove all the gaps from the window height. Window height, you know, right? From here to here, this is nothing but window height. Okay, so we have to remove the gaps, then we exact conductor how many discs are there we can calculate. Okay, now see, the gap at the center of the coil, like tab break, we have to keep 15 mm in center. Exactly tapping mein, it is center mein we are keeping 15 mm gap. Insulator, we are keeping the insulation. Okay, and gap between the tab disc like 1920 2021 21 22, in this gaps mein we have total 6 gaps. In tapping, I am talking about tappings. Okay, the gaps which are I am talking 10 mm gaps we are keeping, 10 mm thickness we are keeping, and 6 gaps are there. If you multiply, you will get 60 mm. Okay, and similarly gap between plane discs gaps I am talking about, there 36 gaps are there. So each one we are putting 3 mm gap, and 3 into 36 gaps will get 108 mm gap. So finally, if you add all the gaps, 43 gaps are there, and how much space is there? 183 mm. These gaps are maintained by paper blocks which shrink during overing. See, we are putting in ovens. In the ovens we are putting this insulation also, compressed one, insulations, right? So what will happen? How it will compress some thickness, because water level will be gone away from the insulation and it get compressed, and that is how much percentage it can shrink also. 66% of the nominal thickness it will shrink. So 183 mm, in that 6% if I remove, like totally 6% if we calculate, I'll get 11 mm is estimated. A shrinkage of 6% over 183 mm. Okay, it will shrink the size, the one which we calculate 183 mm, it will shrink if we keep in oven. Okay, that is 6% of the thickness will generally shrink. Okay, and also we have top and bottom yoke insulation is estimated as 30 mm each of 11 kV transformer. Top and bottom yoke insulation also is there, that is 30 mm we are putting, top and bottom yoke. Okay, the pressure plate of 10 mm thickness is provided at the top for uniform pressing of the coil. To get uniform pressed in top a pressure plate, we are placing 10 mm. Okay. Now we will remove that gaps totally. How much mm is there? We have to remove, and we will try to calculate the size of the strip. Okay. Total gaps between disc after compression. So compression we saw it is 11 mm. We have to remove the total gaps mm is 183. We will remove minus 11. It is 172 mm. And top and bottom yoke insulation, which is 30 mm into 2. Top and bottom, right? So if you multiply, you will get 60 mm. And thickness of the end ring. Okay. The end ring we will keep at 10 mm. One end ring we are putting, that is 10 mm. Now we assume starting with 620 mm window height, right? In that we have to remove this gaps wala plus this top and bottom yoke insulation and plus this thickness of the end ring we will remove. So totally winding is covering 378 mm. Winding is covering. Space left for disc winding. Okay, total disc is all tap and plain disc 378 mm. And we know total number of discs are 44. Now width of the insulated strip for plain disc is how much width? Now we'll get see 378, which is available total windings ka, divided by 44 total number of discs. If you calculate 8.59, okay, with insulation we get. Width of the bare strip taken into consideration of 0.5 mm thickness covering, that we have to remove. We'll get exact size like 8.59 minus 0.5. We'll get 8.09 mm rounded off to 8 mm. So now the conductor width you got. Conductor width you got as how much? 8 mm. Okay. 8. Now based on the current density we have 2.6 ampere per square mm. And the size also, you know, area of the, we calculated area of the conductor. So rectangular area is what? Rectangular area is length into breadth. Like I want to calculate thickness also, thickness of the conductor. Okay. So from this, what is the depth is equal to? Depth is equal to area of the conductor divided by width. Area by width. If we calculate, we'll get the depth 1.82, which is rounded up to 1.9 mm. Therefore, the strip for the planes disc is 8 into 1.9 mm. We got the see width and depth we got. Okay, based on the what? Window size. So window size is the most important to decide. Okay, from there we can get. Okay, now area. Now after getting, we have to find the area of the plane disc. Area of the disc, area of the conductor is 8 into 1.9 minus 0.36. This is a correction factor. Okay, if the conductor size is greater than 1.6 mm, depth I am talking about. If the depth of the conductor is greater than 1.6 and less than 2.24 mm, then the correction factor we have to use is 0.36 mm we have to remove. Okay, so area of the conductor 8 into 1.9. This is the area we calculated. We got 8 into 1.9 minus 0.6. It's the correction factor, is the design parameters. Okay, it is 14.84 square mm. Okay, and therefore, and we have to see whether this current density is within the specifications or not. So if we calculate again 37.88, we know, I told, right, J is equal to I by A. Okay, I by area, current per unit area. If we calculate, we get 2.56 ampere per square mm. We got the plane disc and within the specific limits only. These are okay. Now we will calculate the size of the tap disc. Same way now. The most important aspect of designing disc winding is to maintain the external diameter equal for both plane and disc. This is very important. We are, if see, number of turns for tap windings are less, right? And plain discs are more. This radially, if you see the coil, the coil external diameter should be same for plain disc and tab disc also. This external diameter should be same for plain disc and tab disc. That we should take care of. Okay. In other words, the radial build of both plain and tab disc should be equal. Radially, this is radially. Okay, this is radial build. This radial should be equal for tab and plain disc also. Okay. Keeping this requirement in mind, let us estimate the size of the strip of tab as follows. See, now we know width of the plain disc is 1.9 and insulating covering is 0.5 mm, and width covered with strip is how much now? Covered with strip is 2.4 mm with covering. Okay, and turns per plain disc is 18. So if you calculate, you will get 43.2, which is approximate round up to 44 mm. This is a radial build. This we are talking about radial build. If you see in the top view, this radial build of the plane is 44 mm we are getting. Now for tap also, if we wind also, we should get the same radial build. For that we are seeing. Okay. Now number of turns per tap disc is 14. Number of turns per tap disc. One tap disc, it is 14. Okay. Depth of the strip of tap disc. How to calculate? Total number of disc 44 by the 14. Okay. So 3.14. Like mm radial build we got, right? Radial build upon this number of tap disc. If you calculate, you get 3.14 mm. Okay. Now that's why we are calculating this radial build upon this number of turns. If you calculate 3.14, you got this is the depth of the tap disc, the thickness. Okay. And now we are calculating. We want to calculate the width, right? So assume the cover thickness is 0.5. We have to subtract the 0.5. 2.64 is the exact bare size of the conductor size of the tap disc. Now width, how to calculate the width? We know that area upon this length. If you calculate this depth, if you calculate, we'll get the width, which is 5.7 mm, rounded off to 6 mm. So finally, what we got is number of plain discs are 36. Turns per plain disc is 18. Size of the strip of plain disc is, we got, this is the size of the bare plain disc, right? 8 into 1.9 mm, and covering is 0.5. And similarly, the size of the insulated strip is 8.5 into 2.4. Number of tab discs, this is all one place we are writing. Turns per disc, which we calculated 14, and the size of the insulated tab disc is 6.5 into 3.1. Okay. See, from radial build of the plain disc only we calculate the number of, we got the depth of the tab disc. Now we will see whether it is same radially or not for tap and plain disc. Okay. So here plain disc is there. I want to calculate the depth. This one, depth and width of the bare disc. See, this is the depth. Okay, this is depth. This radial build should be same for tap and disc. So radial build I'm calculating. See, and width means you're talking about this one. This one. Indirectly it is height of the plain disc. Okay. Now see, bare size is 8 mm and depth is 6. This thickness they observed, it is this thickness. Conductor ka size ka thickness, it is 1.9, and 8 is this one. 8 is this one, this width. Okay. So if you see, this is a conductor, suppose the conductor winding. Side view, if you see, the depth means thickness you're talking about, the thickness, and width means 8. This one. Okay. And covering is 0.5 mm. 0.5 I added here. Size of the conductor is 8.5 in this one. How many discs are there? 36 discs are there. 36 of the plain disk. I'm talking about plain disk. 36. If we add, we'll get total height. How much you got? 306. Approximately we are taking as 310 mm. So total height of the plain disks are totally 310 mm. And radially, if you calculate, 0.5, 2.4 you got into how turns per disk. How many turns are there? How many turns are there? 1, 2, 3, 4, like this. 18 turns are there. So if you calculate, it is 43.2 mm you got, and approximately you can take as 44 mm. Okay. Now we will see whether we are getting the same radial build for tab disk also we are seeing. So bare conductor for the tab, I'm talking about tab disk now. The bare conductor is 6 and depth is 2.6. We are adding the covering. We got 6.5 and 3.1. If you number of tab disks are 8, so multiplied, we got 52 mm. So approximately rounded off to 55 mm. Okay. And similarly, radially, turns per tab disk. One turn mein how many tab disks are there? 14 tab disks are there. If you multiply, we'll get 43.4, approximately 44. See, now tab disk radial build is 44 and plain disk radial build is 44. That means if you see from the outside, it is equal level. Tab disk and the plain disk, the radial build, this radial build is equal in all, total uniform cross section, which I showed in the starting the picture. Okay. So if any comments you can do, if any doubts you can ask. Okay. I will be calculating. I saw some comments they asking for impedance, so all things, everything will be calculated till core size, everything, all of the design of the 1250 kVA I will design. Okay. Thank you.